Hello everyone, my name is Piotr Stawirej, and today I'm going to talk about the common and uncommon situations we may encounter during our daily work when it comes to the testing. Okay, what problem am I trying to solve? First of all, I would like to answer to the common questions about testing practices. Those questions were raised by my colleagues I worked with or by people I've mentored or I trained. I would like to also explain the unobvious testing approaches, fill the gap in the testing knowledge between the perfect design when we're starting, for example, some kind of the greenfield, and real life when we are working already in some kind of the legacy system. Why is it important to solve? Of course, save time and money. I would like to make your life easier, reduce probability of creating the legacy system, and I hope you will be prepared for what you may encounter in your daily work and how to create testing strategy for your particular case. What other solutions might there be? I will show common solutions and how they differ from my approach. Additionally, I hope you will extend your testing toolbox. Why proposed solutions? They were tested in the battlefield, so I used them in very simple and enterprise-level project. Those solutions multiple times. They solve the current problems at that time, and they do not introduce new issues in the further development. Try them judiciously, get back with the feedback for me if you have the better solutions or if something doesn't work, or even if it works for you. Okay, without further ado, let's start from the first case. So we know we have a unit test and we have integration tests. Of course, the unit test, we are focusing on no input-output, so we are using the fakes, stubs, so in-memory implementation, and the unit test has to be fast, so 0.1 second per single unit test. Of course, and the integration tests are slower because they are touching the infrastructure. However, this is the perfect design, but what the real life looks like. We have something like this, tests gray area. First time I've heard about this concept from Kevin Henney when he made a talk about Java programming with good unit tests. And what is the test gray area? It is a test which kind of behavior like the unit test. They are easy. Partially, they may use the fake stubs. However, they also touching the infrastructure, and they are not so slow as regular integration tests. However, they are not pure unit tests. And what we can do about this? Of course, we can try to move them to one of those areas. However, we can also embrace it. Use case number one, external system. All the use cases you are going to see today are from my experience, and there were like real-life examples just simplified for the sake of the presentation. So let's imagine we are going to create some kind of the library with new functionality, with some business logic, and this library is going to use some external fast production system. The full context is we are going to implement non-trivial business logic, fast external system. It means we have almost immediate response for it. Running tests against production system will be invisible from production perspective, only reads, so we are not going to pollute the production system. Test run will not increase the load at all. It will be insignificant. Of course, we would like to prefer at the moment to have testing staging environment. However, it was not available. So what was the applied strategy? Only integration tests, and all tests were executed in less than 10 seconds. If we have such fast tests, of course, we can go only with the integration test and don't even bother about writing the unit test. So let's revisit the time criterion. So if we are running integration tests and they take reasonable amount of time and significant duplication between unit and integration test will be present, consider writing only integration test. What is reasonable time? For my personal opinion, it is something which runs less than 30 seconds. But Mr. Speaker, my integration tests already takes minutes. Refactor them, of course, yeah? Thank you, Captain Obvious. So let's take some common example I've encountered multiple times in some code bases. If you are using the Spring Boot test, you may just search in your code base for the annotation dirtiest context and see if you have annotation before each test method. This causes that you are going to reload the Spring Boot context each time. Here is the report of a real-life example of such integration test. We have like 5 integration tests, which took 27 seconds. So how we can fix that? Use old school, just clean the, for example, database in regular old way. For Mongo, you can just use Mongo operations, remove everything for my document. If you have other operations for deletion on your repository, just delete all and create a regular setup method. And then we just reduced from 27 seconds to 651 milliseconds. Recently, I was able to reduce the speed on the real project from 12 minutes to 5 minutes. If you are doing a heavy development on such code base, believe me, this is significant change. Use case number 2, reusing the unreusable context. We have to implement, again, library, some kind of the library B. In our case, with some additional functionality, and we have to use library A. And we cannot change library A. We cannot extend API of library A. We decided not to go with the branching because it would be hard to keep changes in lines for those two forks. 90% of the implementation required by library B is already present in library A. However, it is not accessible, and we cannot touch this library. So how we can overcome this issue? The implementation was reuse dependency library through reflection. So we had another library, and we just opened through reflection the factory methods, which was hidden, and constructors we required, and we used only acceptance test-driven development. So no high-level cycle, no low-level TDD cycles, because we don't want to couple low-level unit tests on code which are using the reflection. Again, the tests, all tests were executed, and this was the integration test used. Again, all tests executed in less than 10 seconds. Why I was mentioning the acceptance test-driven development? For the first week, there was no implementation at all. When you are using ubiquitous language, domain-specific language, you are able to express your requirement, what this library has to do, and we were able to show it to the customer and get their feedback, and we find, before even the implementation started, multiple corner cases which can be clarified before we even start the real work. Use case number 3, external library. So we imagine we are going to implement some kind of the application this time, and this application is going to use some third-party code, so external library. This external library may have very extensive API. This is some kind of the example from internet, so it was very similar to my case. There was a Fluent interface and multiple parameters, but in our context, probably we don't need to use it all. Before the solution, I will show you also the complaints. And the complaints of the clients and people who try to use this third-party library was hard to mock, hard to stop, hard to test. A lot of test methods needs to be mocked, stopped to make tests working. Changes in the external library API require changes in the test setup. Multiple teams and multiple clients reported exactly the same complaints. And I was not the guy who was creating the application. I was the guy who was creating this library. Before the solution, I will show you the very similar case because the solution for the case 3 and 4 will be exactly the same. So we are going to create the application, and we are, instead of the third-party library, we are going to use some kind of the external service. So what is the solution? Do not mock what you don't own. Create an abstraction that covers your needs. Do not use a third-party code service directly. Create a boundary between your code and the third-party code or service. And let's see an example. I would like to implement simple mapping application. I need to access Google Maps to calculate route from point A to point B. Use ubiquitous language from the domain-driven design to express requirements from business point of view. This is our first step. And express exactly what is needed from the third-party code or service. I've noticed this multiple times when people approach to me and they said, okay, how I have to implement this, and this is the API, and they already jumped into the implementation details, what calls to the REST API they have to do, and so on. No, the first question from my side to them was, okay, but what from the business perspective you are going to do? So try to write it in a plain English sentence in the first place. Get route from start location to end location, and this will become your first acceptance test. Create a port in the terms of the hexagonal architecture. In our case, it will be simply routing service. It will return route, get route from start location and end location. So now mocking is extremely easy, but is it even necessary or required? So probably one of the common approaches, we will just prepare some of the expected data and just mock routing service. So routing service get root and then will return some value. But what about creating fakes and stuff without mocking tools? One person who joined our team said, but you don't have the Mockito in the dependencies. Yes, we don't have. And we don't have it for the years. So fake, simulate behavior of a real service, have some logic implemented. There is a big chance you will need them for the other future tests on every level, for example, for the test pyramid. And I notice this constantly when I work on the complex system, when from time to time, when I'm doing the integration test of some part of the system, I would like to, in the fast manner, build this part of the system. And when I already prepared those fakes earlier, for other tests, it is extremely useful and speed up my work. Easier to implement manually than you think, easier to read, maintain, refactor, and customize. We can easily simulate different behaviors, for example, fakes for failing, fakes for success. Sometimes you may implement verification methods in the fake too, then it becomes, by the definition, the mock. One of the common patterns, common implementation of the fake is in-memory repository. We have like get employee by ID, save employee interface, and we can manually implement the fake. As you can see, this is extremely easy. We have some local field with the map, and then just you store the employee in the map and get by ID also by the map. And we are simulating the interactions with the real database. For our case, it will be also pretty simple. Exactly, we'll put to the map. The key will be the from location to location and some list of the expected values, and just in the get root overload it and return what you need. And this is pretty handy for the testing and implementation. However, the real power in the fakes lives also somewhere from the customer perspective. You don't have to build a full-blown application in the first place and give it to the customer to the testing. You can just cut off the infrastructures in the first sprint or in the first iteration. Just go with the fakes itself, deploy this already on the production. So we are not bothering about the infrastructure. We did this multiple times in the multiple projects, not only services, but also libraries. For the library, you can prepare and use some already prepared data it has to return and bundle it together with the jar itself, give it to customer. Customer can then give feedback almost immediately if it works for him or her or not, or some changes are required. The changes at this stage is extremely easy. Additionally, they can already implemented integration on their side and give feedback. So this is the real power of the fakes. Use case number 5, reusing unit test. Having all external dependencies provided through application port allows us to reuse exactly the same tests on other levels of the test pyramid. So imagine we are going to write our unit acceptance test, extremely easy to write, as we know, because they don't gonna touch the infrastructure. They are fast. If we are going to use the domain-specific language, we can show them to the less technical people. We can discuss about the behaviors. And that's all. On the other levels, as an integration test, and even from the REST API, from the graphic user interface, we can run exactly the same test. How it is done? Let's see some example. I'm creating the base unit test for the acceptance test, my app scenarios. It's going to create an application app, which will implement do something method interface. Will have the do something method, and this app will use some kind of the repository, service, and event publisher. In our unit test, of course, we are going to inject the in-memory repository, in-memory service, in-memory event publisher, and we are just going to use factory method to build that and create a bunch of the tests. Pretty simple, I hope, for so far. OK, how we can reuse exactly the same tests on other levels? This is the integration test class, and that's all. First of all, we are going to extend the base my app scenarios class, and only change we are going to do is just to change the setup method. That's all. We are going to inject, instead of the fakes, the production dependencies for Mongo, repository adapter, external service adapter, application event publisher. And from the perspective of the test itself, when we are going to set up this application, it is totally transparent. And we have 4 free integration tests. Okay, let's push it even further. So now we have our test class with the unit test, with JUnit or Spock, whatever, our scenarios 1, 2. And now we have our abstraction of the system. It is app interface. In a real-life example, for example, when you are going to implement chat, then interface will have the methods, behaviors like add, post, delete, reply, and so on. So having this agent, the system abstraction, we are able now to implement the agents. For example, Selenium agents, which is able to talk through graphic user interface with our application, or some kind of the API agent which can talk through the REST API. And we can reuse exactly the same test, unit test, but from the top of our application. Let's see from another point of view. So we have our My App application and Selenium graphic user interface agent, REST API agent, and those three implements the app abstraction, our interface with do something method, and acceptance tests are going to reuse that. How the implementation would look like? Let's see the Spring Boot integration test, for example. Again, we are just simply extend unit test base class with all our tests, so where they will be automatically executed when those classes run. And again, what we are going to do, we are just simply, for example, in the test method, can mutate the web test client because, for example, only authorized people can access for certain REST API. So we will change that. And there will be only small difference how we are going to set up the application. Again, from the point of view of the test itself, it will be transparent. The unit test will not know, acceptance unit test don't know about this change, how the application was built. However, the app REST agent now will use web test client, and our implementation of this agent will look like that for the REST API. So we will use this web test client and just overload. Here, as I said, the app REST agent will implement the app interface, and we are overloading the do something method. So the client will connect to some URI, make a call, get the DTO, and make it the domain-specific object. And again, the application from the perspective of the test is exactly the same. The implementation and the experience would be incomplete if I wouldn't show you the example implementation for the graphic user interface. So we can use, for example, Selenium Chrome driver, and then we are just overloading do something method, and then using, for example, Chrome driver, and Selenium is able to find those text boxes, buttons, and fill the data, click, and retrieve information from the graphic interface. But from the perspective of our tests, which are easy, we are not reusing them, rewriting them. We are just calling exactly the same code. However, we are setting our application differently on every level of our test pyramid. If you would like to make a deep dive for the example implementation of this, because I may understand that this concept can be tricky when you encounter this first place, go to my repository and check out the financial system library. Of course, if we are going to reuse the same unit test and acceptance test on all levels, so instead of the test pyramid, we would have what? The test square. And however, in most cases, it is unnecessary. So how can we follow this test pyramid rule, for example? Extremely easy. In JUnit, just create a unit test method, which simply based on the class file extension. In my case, it would be scenarios. In your, probably the test will detect if it's a unit test. And just use, for example, JUnit functionality, assume true is unit test. So this unit test will be only run as a unit test, will not be reused higher. And this is the real-life example, because in real system, you may just want to leave some unit tests as unit tests and not reuse them as integration test. Use case number 6, time-dependent code. When you are working with application which depends on the code, probably you will find some methods which just have something like instance get now to get current time. And the common approach for the testing such cases is to make a clock explicit dependency, and then in test you are able just to create some kind of the fixed clock with the fixed date time, and then inject this fixed clock for your test. Okay, so this is the common solution. However, when you encounter, as I did, heavy time-dependent application, what does it mean, heavy time-dependent application? Doesn't, or even the whole application classes depends on the time itself. It's extremely easy for the particular class to test it against the clock. However, when you're going to the integration test and you are going to test integration between multiple time-dependent components, it's getting hard. First of all, each component can obtain time in different way by different provider, as we can see instant now, local date time, now from clock, and so on, in some kind of the legacy system. So mocking the time, I don't recommend it. It can be a burdensome. For extremely simple cases, if you think you can just statically mock instant, it is not enough because probably you are using also the local date time now or something like this, and this will require stubbing also additional methods, and it's clumsy and it's hard. What about time flow simulation? It's getting even messier. We probably should create some additional for loop and mutate clock in this for loop, and we are not going to go that road. So what about time flow simulation? What is time flow simulation? Imagine we have a process which starts at the morning and ends at the end of the day. So we are not going to run, for example, or write the integration test which takes 24 hours. We would like to run this with the speed of the unit test and just simulate the time for the whole application. So, and we would like to, for example, validate if certain events were emitted at the particular part of the time, and with of course, some small delay. Probably we can have some scheduler running in the background which processes data and emits those events, and we want those events in the certain points in time. So how can we test it if, in fact, in whole application, we would like to have the one clock? So let's revisit this. We would like to have single code for the whole application, immutable in production, mutable only in tests, both the fixed point in time or simulate time flow, no dependency injection used to provide clock, so no redundant parameters passed everywhere, prevent usage of alternative time providers. And I've came up with some kind of the time flow library I wrote for the projects, when now we have some kind of the wrapper for the system current UTC time, and we are just going to use this singleton time instance now. And then in test, it is extremely easy, because we are going to use the second variation of this wrapper, test time. We are going to obtain the test instance, set fixed clock, and then all you need to remember is two methods: fast forward for the fixed period, fixed point in time, and time flow for simulating the time flow. Let's see the most complex example of this library, which is totally simple comparing to other solutions I've known. So in the first place, we are going to set the fixed clock, and then for the time flow integration test, we are setting up the step. It's a step to jump forward. So for example, we would like to simulate jumping per 1 minute. End time, of course, the end time, and flow speed, millispeed of the simulated time flow. So 1 minute will take 100 milliseconds in our test. Just run your in Spring Boot, for example, you can have this scheduler task running in the background, or just submit some background task right now, and just run the test instance time flow step and time flow speed millis. This will execute and speed up the time of our test. So our 24-hour test will be executed now in like 10 seconds, and just do the assertions. Okay, but what about the different time providers? Because you notice in the legacy application, not only built-in Java like instance local date time can be used, but other. And what about our library? So we can use, for example, and it was used the arg unit, so we can prevent using test time wrapper in the production code. We can prevent instant now, clock, local date time now, and other providers. So if new person will join the team, the just simple arg unit test will fail if it will not follow the convention. It is already in our repository. Use case number 9, internal cache. Constraint: do not expose the cache to the client, and our application is going to use the cache. And in fact, we have from the point of the unit test no visible action result, because if we are making some request to the database and it's used cache on the unit test, it's the same speed, almost the same speed with the cache and without cache. So we would like to check if we are using the cache. So imagine we have the library which has the field cache, a private constructor which assigns this cache. Then in the factory method, we are just using, for example, caffeine library. when we are building the real-life cache used by this library, and have some method which uses this cache. How we can test it easily? One of the very powerful and one of the most commonly used patterns from my work is extend and overload pattern. So how does it work? Now we have to do some alterations. Again, a bit of the gray area of testing, imperfect life. So we are now not exposing totally the constructor, just a little bit, and we can live with that. So make the constructor protected, and then extend the library class with the test library, and overload the constructor. And now we can indirectly in our tests test the library, injecting some test cache. As we can see, this is the caffeine new builder record stats build. So we are going to record some statistics, and then we are indirectly able to check if our application uses the cache. Yeah, and we see at the then section, then cache statistics hits count is equal to 1. Use case 11, asynchronous code. Let's imagine we are going to create an application, some kind of the subscribers, which reads content from the queue in a thread and sends processed content to some external system. We have some in our system, we have some kind of the publisher application which publish on our queue, Kafka, Nuts, whatever, and then our application will read from this queue and sends the data to some external service. Okay, so how we can go with testing this kind of the solution? Some common approach is to just prepare the required dependencies. So let's prepare queue, new instance. We can use the test containers to set up the real life like Kafka or Nuts or something like this. If you are interested more in the test containers, please join the Piotr Przybył. After the lunch, I believe he has a workshop about the test containers. Then we are preparing some kind of the service mock, so our end service. And we are building our subscriber with new instance, and we are going to inject those queue and service mock. And what we are going to do next, of course, we need to feed our queue with some messages. So let's feed it, publish the message 1, 2, 3. Run our task, which we are going to test for the subscriber in the background. Let's make some delay. I will get back to this in a second. And then just stop the subscriber, and let's check if our received messages on our mock will contain exactly some processed messages. Okay, but we have a little trouble there. What about this thread sleep 5 seconds? It maybe looks nice for the one test. However, imagine you have a lot of integration tests or unit tests which uses this kind of the solution, and 5 seconds for the dozen of times or even 100 of times, extremely slow tests. So how can we overcome this issue? Let's use, for example, the awaitility library allows us, but the technique is called the sampling. So we have our probe. What is the probe? Service mock receive messages count 3. So we are now polling after some 10 milliseconds delay. We are doing after this poll delay. So let's allow our system to start. Let's with the poll interval 100 milliseconds. So every 100 milliseconds, we are going to probing our system if it has stabilized. So what does it mean? If it receives our 3 messages. And we will gonna do this at most for the 5 seconds. In 99% of the time, it will be much faster, and we will not have those ugly fixed 5 seconds delay. So sampling or listening, we need to have an observable effect. So sampling, repeatable polling system for state change. Separate sampling from sample validation to have clear probe. Yeah, we already separated it because we have awaitility allows us in the different method to set this polling interval, and we have the separate part for the probe, which is probing the system. And in case we have application which emits some events, just use the listening, so we are just going to listen for the events the system sends out. And what if we have the same system state at the end of the test? at the assertion to check the system immediate state. This is against the canonical test structure, which means we have the given sections when we prepare the data for the test, when we have the then sections, when we execute the behavior of our system under test, and when we have the then section, when we are asserting the business behavior. However, now we are violating this consciously, and we are introducing some intermediate assertions to verify if we had those intermediate state. And it is crucial, not only for this part, but for every test you are going to write. If you are, for example, working in the acceptance test-driven or the test-driven development way, so see the test fail. And multiple times I was shocked because I wrote the test, I was expecting it to fail, but it was green. And I had to figure it out where is the mistake, or the functionality was already implemented, and if it was the test for it or not yet. So what's the issue here? No visible effect. Imagine we are going to test no visible effect. What is no visible effect and how to test it? So imagine, we will see an example in a second. So we could pass the test even the application was started. We have no visible effect. So for example, we will see that we are going to post messages which are going to be ignored. And in fact, we have the 0 messages at the return, no effect. So we need to ensure the system has started and performed no effect action. We need to trigger behavior which is detectable and use results to validate if system has stabilized. This is the example. In our case, it would be publishing on the queue only ignored messages. So those messages will be ignored during the processing by our service, and then normally we would write the test that service mock received messages count 0, but what if we made a mistake? We don't even start the application, or there was an error which didn't process those messages. The test will pass. So now let's mix no visible action effect with something which we can detect. So let's put in our queue also the message to, which should be processed. And now, what we are going to do with our probe, it's going to search that at least one received message is here. So we now ensure that our system starts, is working, and our service mock contains only processed message. So system works, and we just tested no visible effect action. Let's go with the fault tolerance and resilience. So let's again imagine we are going to create a library. Apparently, I was working a lot of and creating a lot of libraries in my life, so a lot of examples from this area. And this library is going to read and write from some kind of the external service. And we would like to test the fault tolerance and resilience. So the good idea is to separate functionality, our business rules, our behaviors, and separate it from the handling failures policy. This allows us unit tests, just write a simple unit test against the fault tolerance and resilience, and against the business rules, and not mix them together. So how can we achieve that? We can use, for example, well-known decorator pattern. So instead putting the fault tolerance and resilience in our my library, let's decorate it with the retry library. And retry library will retry failed executions a certain number of times with a delay between attempts. How it will look like? So we are going to create library interface, which, for example, has a method get users count from some service and return the number of the users. And then implement our library, which is one of the methods could be override long get users counts. Here, fetching users count, we can use some UniRest or some any kind of the library which allows us to connect to some external service, for example, through REST API, and then return the users count. But we are not handling here any fault tolerance. We are not retrying here anything, just simple call, and it may fail. And what about handling the handling the fault tolerance. Let's create our decorator. So we are going to implement our library interface by class retry library. Then we are going to create a field for our library as it is in the decorator, because we are going to inject at some point the original library. And then we are going to create, for example, retry policy. When you encounter the could not fetch users count, so with delay of 1 second, just try to make a retry and try to make it 3 times. Then, of course, well, let's inject this through the constructor. And here we have the fault tolerance. And it is separated from the place when we are going to have the connection to the external service. So we are using, for example, the failsafe library. So with retry policy get, and here is the original call or our base library. And failing library will implement the library itself. And sorry, this is the fake. So now, when it comes to the unit testing this, we are able to just create a simple fake. As I mentioned at the beginning, the fake can implement some kind of the logic which imitates the real system. So we can put some kind of the parameters, the attempts and fails attempts. So we can now make a test which, for example, do in our failing library fail after 2 retries, fail after 4 retries, and so on, and check if, in that case, our fault tolerance will work correctly or not. After some attempts is going to be exceeded, then return the value, which is, of course, fake, but it imitates the real value returned from the external system. And in our test, we can, for example, retry when failing fetch user count. We can now create the fake for the external library, so our base library with the value 2. This will fail 2 times, and we will just call the method getUsersCount from the retry library, and we'll see that it will in fact behave correctly. It will do the retries and return value. And of course, we can extremely easy and do extremely simple testing for the failing part. As I mentioned, we can now alter the behavior for our failing library fake. Let's put the value 4, so we know that we are going to do 3 retries, but now the fake library is going to do the 4 retries. So when we are going to call retry library getUsersCount, now we are expecting the throwable could not fetch users count, and with some message server is down or whatever. Use case number 13, multi-threading. So let's push with this idea even further. So in the previous case, we were separating the fault tolerance and resiliency and business rules. Now we are going to separate the business rules, functionality, and the concurrency policy. So we would like to test functionality and concurrency, multi-threading, synchronization, and so on separately. So in executor, in our concurrency multi-threading environment is pretty big thing. So let's make it an explicit dependency in our API. This will simplify development. We can unit test behavior without minding on the threading issues. Concurrency policy is explicit dependency. It should be exposed in the API. And we can inject in test different concurrency policy, exactly as we just inject different fault tolerance policies. So let's see. And if it comes to the multi-threading, there is a bit more. So let's remember to synchronize your test threads with the background threads. So we don't want to test to finish before the background threads. Set test timeout. Sometimes it is necessary. And remember, because you may fall in the pitfall, like if you are not going to synchronize some methods for your mocks, fakes, and spy, which gathers during the parallel processing some additional data, then you may have the verification data scrambled, and it will be hard to test. So also it is required to minding on the synchronization for the fakes and spies and mocks part. And let's see if we are going to test only some business logic for some kind of the search behavior, and we would like to not mind anymore at this point about the threading. So we can use, for example, from the JMock library, the deterministic executor, and in our search application, just use this executor, as I mentioned, as an explicit dependency. And the output, as you can see, is pretty clear because we have some inside, we have some kind of the multi-threading, but it is now like disabled from this perspective because we have like search enable A is running, A is done, B is running, B is done, C is running, C is done. So we are in total control how our threads are now running, and we can focus on the behavior and not minding on the threading issues in this particular threads. And we can clearly and has an extremely easy way to run those applications, route those threads, stop them, and so on, and just validate the result. And when it comes to the validating if the threading real-life policy is working, let's create the real-life executor service. And we can see we are creating executors, new fixed thread with the 5 threads, and then inject the real-life executor service. We already learned how to wait for threads to finish, so call our behavior, search for some query, wait for the result, and then we are now able to only focus on testing if our multi-threading environment is working. So it will be easier, much easier to spot the errors, and we are not mixing the multi-threading and business in the same test. As we can see, we run the real-life executor service because the output is a bit scrambled, so we have the runable for CBA and CAB is done, so we can see we are not controlling it as it was previously. One additional thing when it comes to the multi-threading and concurrency testing, build some kind of the abstraction on top of your concurrency and multi-threading in the test. I mean, for example, I had a test when I would like to check if the bug was fixed, and 40 times I was running in parallel some kind of the method and just collided. So simultaneously I was running the same method and check if no concurrency errors was present anymore. So putting all the stuff which is required to set up the test and check those using the built-in Java tools for the multi-threading and concurrency, it will be, I will not show this because it will be unreadable. There's pretty large number of the code lines, and it is clumsy and it's unreadable. Just build an abstraction in some kind of the abstract domain-specific language. In our case, from my business test perspective, it was like threads collider, and what is only important, I would like to check if HTTP max connections per host, it was like 40, and with seconds await 10. I was building this thread collider, and then I would like to collide my method and just check if there were some overlaps, so those multiple methods were run at the same time. Additionally, the latch count is 0, so there were no issues, and also this code did not throw any exception. Okay, so this is the examples so far I've prepared for this talk, and heuristic I can give you, and maybe you already spot what I was focusing on each of these cases, is the single responsibility principle. And of course, the single responsibility principle states that class should have one and only one reason to change. Class should be responsible before one actor. However, my comment is on whatever level of abstraction you need, function, class, module, abstraction should encapsulate single behavior. And I know that in many blogs and YouTube videos and on other materials there are endless discussion what in fact is this single responsibility principle. So let's allow me to give you something more tangible, something you can in fact calculate and check. It is called the cohesion, and we can see and check and calculate cohesion. How? So let the cohesion guide you. We want to have the classes which have the high cohesion. Each method manipulates as many class fields as possible. High cohesion where methods and class fields depend on each other and are logically connected. If some class fields are used by subset of methods, probably we need to extract a separate class, separate behavior. Let's see this for a very simple example of the stack. We can see that we have two fields in this class, top of the stacks and elements. Yeah, pretty simple. And if we are going to examine all the methods presented in this class, so we can see that top of the stack is used by the size, top of the stack and elements are used by push, top stack and elements are used in the pop method. So as we can see, as we can see here, we are manipulating in our methods with, we are working on all fields within this class. And what in this class is high cohesive or not? High cohesive, yes. And if we have a subset of methods which manipulates on the subset of fields, this is what you can spot by automatic tools, but even on some kind of the pull request review or whatever. And you can see, like, I have these 2 fields manipulated by this group of the free function. I have like those 2 fields manipulated by other 5 group of the functions. This indicates, like, in fact, we just merged 2 classes or 2 behaviors in one class, and we can separate them to the to the 2 distinct classes. Yeah. So single responsibility. But if you don't know if this is my single behavior here, just check the cohesion. And test strategy is a conscious decision. Who is using the architecture decision records in the projects? Great. Who is putting what kind of the architecture is going to be planned for your project? Okay. And who is putting what the testing strategy is? Yeah, few people, okay. So this is the conscious decision. And of course, we put in the architecture decisions some architecture drivers and constraints and so on, but also next to the architecture itself, we need to think about the testing strategy. Is it going to be test pyramid? Is it going to be honeycomb with only integration test? Is it going to be some custom solution here, and what's the reason? So this is the conscious decision, and it has to be selected up front. If, of course, any changes will appear, also they have to be reflected in other architecture decision record. Okay, thank you for this talk. I'm asking for you to fill up the feedback form in the Google application, not Google application, in the Devoxx application, of course. If you would like to download the presentation, here is the QR code and the link. If you have any question, just approach me after this conference. We can discuss about your topics, your problems. If you would like to make a deep dive on certain topics, just give me a hint. Connect with me on the social media, whatever. Thank you very much.